This is M.Revathi, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Sciences. In this series, we are going to discuss about the logical programming prologue. So today we are going to see about backtracking, cut and negation. First, we see what is backtracking. Backtracking is a problem solving and search technique used in programming, especially in logical programming language like Prolog, to find solutions step by step and go back whenever a dead end is reached. So when we write program in Prolog, the system is trying to find answer by following logical rules and facts. So the process it used to explore possible answer is called backtracking. So it's a search mechanism in Prolog. So let's break it down by step. A search for a solution, Prolog starts from the first goal. Then tries to find a fact or rule in the knowledge base that matches it. It explores path. If it finds a rule that might work, it follows the path and continues checking the next goal step by step. If failures and occurs, the backtracking, if Prolog reaches a point where a goal cannot be satisfied, it does not stop. Instead, it goes back. This is called backtracking. So to the last decision point and tries a different rule or fact. Finding all solutions, so the process continues until Prolog has either found all possible solutions or confirmed that exist. For example, suppose you ask Prolog like Raj, X, it will first find one value for X that makes the statement true. If you ask for more solution, Prolog will backtrack and check if any other X are also satisfy the conditions. Next, we see how backtracking works. So backtracking is a step-by-step problem-solving method where the system explores different possibilities to find a solution. So the process starts by attempting the first rule or choice. So first start from first rule. Next, the process, if the choice successfully leads to a solution, the result is returned immediately. It returns the solution. So if it fails, the system go back previous choice. So this process is called the backtracking. So in this diagram illustrates this process is clearly starting from A node and the system first move to the B and explore further or D or E. If none of the leads to success, it backtrack to again A and try the next branch to C. Then it continuing with F and G. The cycle continues unit all paths are explored or a valid solution is found. So in simple terms, a backtracking is like trying every possible route in a maze. If one path is blocked, you go back and try another until you find the correct way out. It ensures that no possible solution is missed. Next, we see what are cuts. So here we are using the cut symbol. It is used to control backtracking. So Prolog automatically explores all possible rules and choices to find every solution to a problem. So when a cut is encountered, Prolog stop looking the alternative path beyond this point. This means it commits to the decision made before the cut and does not backtrack to try other possibilities. So the main purpose of using it is to increase efficiency by preventing unnecessary searches or to force determinism, meaning the program will produce only one solution if it only cuts. So in this diagram, it illustrates the cut works in a search tree. So once the cut appears, all the other branches that could have been explored are pruned. Prolog skip them entirely and continue only with the current path. Next, we see the types of cuts. There are two main types of cuts. One is a green cut, another one is a red cut. So the green cut is used purely for improving efficiency. it helps Prolog avoid unnecessary backtracking without changing the logical meaning or correctness of the program. In other words, even if the green cut is removed, the program will still give the same results. It will run a bit slower because it performs more searches. On the other hand, a red cut not only affects efficiency but also change the logical behavior of the program. So it is the altered program meaning. It means so it is used to control the program's logical flow by forcing Prolog to follow a specific path and ignore others. Removing a red cut can change the mechanism or output of the program. So therefore, green cuts are considered safe, while red cuts must be used carefully as they can make the program harder to understand or debug. Next, we see the backtracking with negation. So negation lies on backtracking. That means the Prolog tries to prove a given goal, and if it fails to find any evidence that the goal is true, it concludes that the negation on the goal is true. So in other words, if Prolog cannot prove something, it assumes it is false. This process relies on backtracking. So where Prolog explores all possible rules and facts to try satisfy the goal, only when all attempts fail does the negation succeed. Next, we see the today's topic, the mind map. So the backtracking cuts and negation Prolog. It's a first one is a backtracking mechanism, cuts and backtracking with negations. So in backtracking, we seen about the purpose and what is the flow of the process and action of path fail. In cut, what symbol we are using, how it functioning is working, and what are the types of cuts. So backtracking with negation, it's we seen about the mechanism of backtracking. I hope you enjoyed this section. Thank you.